All right, welcome to Beyond Nagios, modern monitoring of Bronze Age applications with Prometheus. My name is Ben Kochie. I'm an SRE at SoundCloud on our production engineering team. We manage all of the infrastructure software required to run the SoundCloud platform for all the product teams that make the actual software for SoundCloud. A little history of me. I've been in ISP, IT, sysadmin, SRE changes over the years for about 20 years. I got into high-performance computing in the early 2000s, and then I got into the SRE thing at Google in 2005. And the last 3 years I've been at SoundCloud trying to bring the SRE ideals to a smaller startup. A quick thing, how many people here are familiar with Prometheus? So, good, I was hoping everyone from your audience, so we'll kind of skip over that. And what we're actually going to be talking about today is a piece of software we nicknamed Mothership. And Mothership is SoundCloud's classic Rails monolith. If people are familiar with Ruby on Rails, these applications can grow to immense size and complexity. And the thing that seems to be the popular thing to do now is we try and break up these giant monolithic applications into smaller services to reduce the complexity and increase the feature deployment speed of each of the individual components. And being a classic Rails monolith, it's got one giant database and a very large deploy footprint. And since we are actively trying to reduce the code base, we're deleting features, moving them out, building new services to replace the subcomponents of the Rails monolith. So the Rails monolith itself is kind of on minimal maintenance mode. And when I started at SoundCloud, there was pretty minimal alerting to let us know that there was something wrong with the monolith. And Prometheus at the time was fairly immature. But as Prometheus matured, we started to say, hey, wait a minute, we should probably bring some of this great specification to the monolith. So over the last couple of years, we've been able to do this migration from classic monitoring tools to Prometheus. The Mothership itself already had a whole lot of interesting instrumentation. The first one was New Relic. And New Relic is one of these super nice tools for small Rails applications and other types of apps because you just drop in their plugin. It gives you all kinds of detail, lots of debuggability, and it's actually quite nice. But there's some downsides. Some of the biggest downside is it's really expensive. I did a bit of math to figure out how we're using New Relic, and like, hey, why are we only running New Relic on a small 5% sample of our servers? Well, it turns out that 5% sample was costing my salary every month. So it would be economically infeasible for us to actually deploy New Relic to the entire Mothership. So we only had a small 5% sample of servers instrumented, which was just like, wait a minute, we're only looking at, when I look at New Relic, I'm only looking at a 5% sample of our app. What if all the other 90% of our servers are down? Well, we don't know. So we needed other things. Other problems with New Relic. Its data aggregation is by minute. And you always see this there. Everything is in New Relic is by minute, so it's pretty low resolution. So you can't see small spikes. And there was a time when, after we added Prometheus, that we discovered, oh, wait a minute, there's a small 5-second burst that's hidden in the noise at the top of the hour every hour, and it's hitting from one subsystem, and it was actually causing errors to users. Because the Android devices were waking up on the top of the hour, it was the top of the hour, and they were all Android devices on the entire planet were hitting our servers simultaneously. or maybe not all, but a pretty big chunk of them. And with New Relic, we couldn't see that, but with Prometheus, we could. The other problem with New Relic was the user interface is their user interface, and you only get to see it the way that they want you to see it. So you don't have the flexibility to access the raw data that New Relic collects, which is a pretty big downside when you want to have a good dashboard view for an on-call incident response. So it's great for general browsing, but not for incident response. Another thing that the mothership had is StatsT. Because the Rails app is basically single-threaded, there's no way to get to it other than its HTTP interface, but that's blocked responding to requests. So early on, before I worked on this, there had already been some work to instrument the mothership with StatsT, but there are downsides to this. In the original version, all of the Rails binaries were sending their metrics over UDP to a single collector in production. And it turned out that 70% of the samples were being lost because of UDP drops over the network. And one of the Prometheus developers actually fixed this by adding StatsT aggregators on every node. So now we had, and then building forwarders, but we were still losing data. It wasn't accurate. So there's a big downside to the way StatsT's UDP protocol handles data. And then StatsT, we would take all the data from StatsT and send it into Graphite. We'd also take node-level metrics from Ganglia plugins and send that into Graphite. And that was actually not too bad. I got a lot of really good instrumentation done of Mothership by building new views into the Graphite data, because we had all this data, but nobody had really put the time into thinking about how to visualize that. And I got us about half of the way to a really nice setup just by using Graphite's data. But Graphite is not fast enough to keep up with the amount of servers. The mothership runs on about 200, 250 servers, full bare metal, hardworking, using lots of core time, handling tens of thousands of requests per second. So Graphite couldn't keep up with the amount of data we wanted to collect to really get good insight into what was going on. Plus, the data model is a bit limiting, and if you compare the Prometheus data model to the Graphite data model, everybody knows that the labeling is just way better. Another one that instruments Mothership is the Airbrake. Airbrake is completely unrelated to Prometheus. It simply forwards exceptions so code crashes within Mothership. It forwards that off to Airbrake. This is an unsolved problem for us because Prometheus doesn't do this. It's not what Prometheus is for. So it's still actually quite useful to use Airbrake for monitoring. But I find that some people really like it. I find the user experience as an engineer highly frustrating. The most hilarious thing is if you get a spike in exceptions on their graph, you can't click on it. It's completely useless. It won't actually. You can't even select a time range to get that data to find out what happened in that Airbrake window. Like there's a spike, but what is it? No, I don't know. You can't, and it only shows you by latest exception, which could like small low frequency exceptions can just scroll off the high frequency exceptions, and you don't actually know what happened, and you end up spending 3 times the amount of work chasing down. Was this the one that was in the spike? Was this the one that was in the spike? Was this the one that was in the spike? You just don't know. But unfortunately, that's not something we can fix with Prometheus. And then to actually get alerts out of the mothership, we have Nagios. And Nagios is everybody's favorite thing? No. It's a pretty terrible broken data model for alerting. It's super slow. It's super annoying to configure. But we were able to get some things like using check HTTP to monitor the passenger, Nginx passengers that would run the Ruby on Rails. And then we would use check Munin to go into our HA. We had Munin stats for HA proxy. And that was pretty much it. So we could tell that we were sending errors from HA proxy. And we could tell that the passengers were running. But that was pretty much it. You couldn't actually get information about what was broken, so you would have to go and tail logs and look at things, or go to New Relic and try and figure out from logs in New Relic what was actually going on. So Prometheus is what we wanted to get the mothership back up and floating. So Prometheus, for the people that don't know, is a time series-based monitoring system. It pulls all the metrics that it pulls all the endpoints of the data that you want and aggregates it and allows you to write alerts and graphs. The first thing that we instrumented in the mothership was we wanted to instrument the database that runs the mothership. So the MySQL database, we wrote the MySQL exporter, and this gave us really, really deep insight into what was going on the database side so that we could improve performance and latency from the database's perspective. MySQL's performance schema is a hugely, hugely valuable data mine, but it's really hard to look at because the only way it presents it is in SQL. So you have to do select statements against it, and this is really not useful. So Prometheus collects that data, turns it into a time series, and now it can do stuff like this. So this is a performance schema example where I can take and look at the average number of rows examined versus the average number of statements. So now I can get a graph of how many rows per query are required for a particular query. And this tells you an approximate cost for that query. And now I can look at a graph and see, oh, these are the top 10 select statements that cause me super expensive. I think the number over there is something in the like 400 rows per query are needed to resolve that query. And that can be, and there are periodic problems. There's constant problems and there's periodic problems. So we can go and look and see, well, is there a bad API or a bad index, or is there somebody scraping us? We can now have a target for investigation based on the tables affected by these. The next thing I did is a total hack. A Google engineer wrote this really nice tool called MTail. And MTail just tails your log file, parses it with regex matching, and turns those regex matches into counts. So now I can count every log line. But with Prometheus, I don't just get the count of log lines. I can pull out little bits of data from each log line using the regular expression pattern matching and put those into labels. So now, with a little bit of tweaking of the Rails log lines, I can now say, well, I have the info. Well, sometimes it's info, sometimes it's warn. So now I can have counts of log lines by info or warn. I can take the time out of the timestamp there and actually have a count of time spent. So now I can get average latencies. And then a little bit, and plus, of course, we have the status code, so we know whether we're sending a 200 or a 404 or a 500 or whatever the HTTP status code is returned by the Rails controller. And then with a little bit of tweaking to the Rails code, we appended the Rails controller and action. So basically, what function within Rails was being called and what mode it was being requested in. And so now we have latency, errors, responses by action by controller. So now we have all of these dimensions, and now we have time series for every single one of those. And we can now take these with this MTail configurations. This is a contrived version of what was actually in our production configuration. And we pull all those things out, and now we have all of these labeled values, and we can actually start writing alerts. And now we can actually get an alert for a single controller and a single action from every instance of our Rails app, and know immediately what's going wrong, instead of going, oh, Mothership is returning errors. I better spend half an hour investigating. Now I just get an email that tells me exactly what controller is malfunctioning. Here's a dashboard example of looking into a single specific controller. So you can see the responses by action. You can see the response codes by coming from the controller, and we have a latency graph down on the bottom here that tells us the latency by action. So I can see that index actions are nice and fine. There's a little bit of noise in the create, and there's actually quite a bit of noise, but maybe that's because there's not so many. There's some smoothness problems with when you're trying to do average latencies. But this particular controller handles people posting comments on tracks. So we get 200. At this point in time, there's 200 requests per second to post to look at comments per track, and maybe a few per second of people posting new comments. And then we have a zoomed-in error, and that's actually a different Prometheus query that tells us the increase of errors over the last 5 minutes, and then it's blocked in 5-minute blocks. So you can really see if you have a very low error rate, you can now see that super low error rate because Prometheus allows that flexibility in query language. The downside to MTail here is it's super expensive from a CPU perspective. It costs about 10 to 15% of Mothership's CPU capacity to just tail and process all those logs. So for every one of our servers, if it's running 10 cores of Rails, it's running 1 core just flat out regexing logs, because we're generating tens of megabytes of logs per minute per node. So 200 nodes we're generating gigabytes per order magnitude gigabytes per minute of logs from these things. But because it's MTail is distributed on every node, it's actually pretty scalable. StatsT actually is a totally great way to get data out of something that is single-threaded. So if you've got PHP code or Rails code that's single-threaded, or some other thing that isn't a persistently running app, or doesn't have any persistence threads, StatsT sending out to that localhost aggregator is actually pretty nice, because we can take those StatsT metrics, use the Prometheus StatsT exporter, and turn those into counts that Prometheus can come and collect, and then graph in time series. But the trees are a little messy, and you have to be much more diligent in your code to do this. So I had to do a bit of code cleanup to actually make some of these StatsT metrics useful. So we had some metrics for memcache usage, and there's one piece of code that would count the number of hits and count the number of misses, and there's a different piece of code that would count the number of lookups and the number of misses. Well, lookups is the sum of hits and misses, so we had to fix that. Plus, there's not enough context in here. It's like, wait, user or user whitelisted, where is that coming from? So it turns out it was actually, one was coming from a Rails model, and one was coming from a Rails service. And that's Rails specific things. But now I started cleaning up all this StatsT names, and moved the hit to actually count lookups. So now we have consistent lookups and miss metrics. And then I used the StatsT mapping in the StatsT exporter to turn that into key value labels for Prometheus to collect. And I don't know if I have any good graphs of that one, but it turned out to be really useful. So we could actually start alerting in Prometheus on cache miss problems. Here's the example of the new Relic thing. It's actually quite a nice interface, but you can't customize it as much as I'd want. And then here's this similar like application overview, and it gives me the things that I really actually care about, which is which top controllers are having errors. So I can immediately look at a graph and see which controllers are causing me problems, and then and also looking at latency. Whereas New Relic tends to focus on their AppDex score, the overall throughput of the entire thing, and then, but it really does have this nice stacked latency graph for different subsystems. So that's one thing that I haven't been able to reproduce in Prometheus yet, but I probably could if I actually went into the Rails code and added some StatsT metrics on this latency to get that data out. So what's coming up in the future for Mothership? Right now we collect latency, just average latency, but improvements to the MTail code now allow us to actually add histogram support. So we can now bucketize the latency response for different controllers. I want to continue doing the StatsT cleanup. We want to stop sending. We still send the StatsT to Graphite, but nobody looks at it anymore. So we just need to turn that off. And I finally want to remove that last bit of New Relic. Oops, that's done. I just did that yesterday. All right. Any questions?
Is there a library you use for Prometheus to swap out StatsT?
No. So the StatsT. So is there a library to swap out StatsT? Well, so there's the Prometheus library. So if your code is, if you can load the Prometheus library into your code, you can swap out StatsT that way. But of course, you'll have to. It's not the same exact semantics, depending on your programming language.
It's not one for one.
It's not exact. It's you would use it the same way. You do increments and you do sets. So you set a metric or you increment a metric, or you. But it's not exactly this not exactly the same. So you would have to add it in, or do a code search and replace. But what we were doing is just using StatsT out to a node local StatsT aggregator.
So is there a reasonable resource of kind of curated Prometheus queries against, there are kind of certain types of standard metrics, and there's some really good examples in the Prometheus documentation about how to build AppDex and how to build create per second or whatever. But are there deeper resources kind of like, essentially recipes for?
Yeah. So the question is, are there deeper recipes and other best practices for producing alertable alerting queries? Yes and no. You touched on a couple of them, like the AppDex score. No, there aren't. Early on in the Prometheus days, we decided to leave that for later because we didn't want people copying and pasting bad ideas. So right now, it's really think about your SLOs, think about your SLAs. What things matter to your users, and what things matter to your engineers, and just draw a line in the sand, and if it's over that line, that's an alert. So, for example, high persistent latency, high persistent errors, large spikes in errors, those kinds of things. That's a lot of that is actually really well covered in the Google SRE book. There are lots and lots of things you could alert on, but you really only want to pick the things that matter to your users. Next question.
So, I think we have the same ideas about how we feel the same about New Relic as sort of you do. Do you get the same granularity Right? And so the reason we haven't turned it off is that when things really do crap out, we get just crazy granularity as to like what's happening in Rails, what's happening in MySQL, and it comes for free as long as you sort of include that gem. You just kind of get all that.
Yeah,
because you sort of have to build that yourself.
That's yeah. So the question is, how do you overcome some of the extra bits that you get in the new Relic model? And the big one for me that was is like the sample event stuff in New Relic is actually really useful. And what do? We're kind of just living without it.
Have you looked at the open tracing stuff?
And yeah, so the question is open tracing. Yes, open tracing is probably the answer there, or some kind of tracing, or something like Airbrake. But yeah, having the logs is, and what we're working on right now is just making really easily searchable logs. So we try and just up the logging verbosity and put as much information into the logs, but only keep logs for a very short amount of time, so that we don't overwhelm our logging cluster. And that way we get the tracing in the logs, and we're building basically a highly searchable logs cluster using Kafka and Elasticsearch. Anyway.
How is managing a Prometheus backend compared to managing Graphite?
Oh my God, oh my God. How is managing Prometheus compared to Graphite? That is entirely why we wrote Prometheus in the first place. It's super easy to run a Prometheus server. You give it a config file, you start it up, you're done. It's one binary, it reads its config file, and you just let it do its thing. It's just hilariously easy to run. So because it's so hilariously easy to operate Prometheus, we have 30 of them monitoring different applications. So instead of having one big giant Graphite that does everything, and it's like nobody wants to touch it, nobody upgrades it, it just sits there. No, we just have this Prometheus monitors this app, this one does this app, this one does this app, and if they break, well, we don't care. We just hit a button and a new one pops up. So it's so much easier to operate.
Right. I was going to say the same thing. Like Booking.com has this crazy cluster of
Yeah.
Graphite. They've written special Go versions of parts of Graphite to speed it up.
Yep. Yeah. So yes, you can automate Graphite, but it's still a little bit more work from what I've seen. And Prometheus, we didn't have like the Prometheus itself didn't have to do much work, and it can handle significant amount more data. You know, the Prometheus server that's handling the mothership is ingesting, I forget, I think it was about it's actually only about 600,000 time series for that server, but it's handling about 50,000 samples per second, and it's idle. Yeah.
That number of time series, what is your memory usage for Prometheus?
What is the memory usage for that Prometheus? I don't know. I'd have to log into the cluster. Maybe I don't know. Let me ask.
Yeah, if you look in the Stack Overflow, there seems to be quite a few issues about Prometheus generates OMs around the large number of time series. So you have to be careful configure your chunks and support, otherwise you're going to have I've run quite times to run that bit.
Hey. Yeah, there's a little bit of configuration for bigger servers, but it's pretty trivial, and it's all templated in our deployment. But let me find out. That should be a relatively easy question to answer. This Prometheus server is only using about 17 gigs of RAM for time series, and yeah, I think we have a 2 or 3 month retention, and it's only 400 gigs of disk space. So it's one.
And what is your cloud usage? You aggregate every 24 hours?
Say what?
What's your granular data retention? Most granular levels?
This is a difference between Prometheus and Graphite. Prometheus does not downsample. So we have full time series data for the entire 2 month retention period on that server. Actually, let me tell you exactly. This one is storing. This one is actually storing. Is that right? Oh, this one is storing 1 year of data. And it's only using 450 gigabytes of SSD space on this server.
What were you using for alerting before? Was it Nagios? Are you using the new Prometheus alerting?
So the question is, what were we using for alerting? We were using Nagios, and now we're using Prometheus alerting. And but yeah, so the performance-wise, this Prometheus server is using less than 1 core, and come on, Wi-Fi is slow. We only really need about 300,000 time series from the mothership, and this is not a very big Prometheus server compared to, say, our global MySQL database Prometheus server that's doing 1.5 million time series. So then that's another nice thing is we can isolate. With Prometheus, we isolate different applications on different servers. Another question?
I would guess the bulk of that 600,000 is per endpoint metrics, right?
That's a good question. What is the bulk of all that data? It is, yeah, a lot of time series for those endpoint metrics, because I think there's something like 30 or 40 controllers with however many actions. And you multiply that because we have a time series for every single Rails server that's running. So it's actually quite a lot of granularity. But this is nice because I can either get an overall view of errors per controller, or I can get an individual server's errors per controller. So I can find individual servers that might have a broken network problem or some other corrupted file.
We're doing roughly the same thing, but with the histogram data, I think you have like 600,000 data points too, and it's a very terrible balance for like recording rules. And
yeah.
How to graph that data without annihilating the server.
Yeah. Basically, so how do you not annihilate your Prometheus server? Basically, anything that we put on a dashboard eventually becomes a recording rule, so the dashboard just pulls from that pre-recorded data. Which makes the dashboard super fast. But really, 600,000 time series is not actually that much for Prometheus. It's totally in a normal load level for Prometheus. Although we do run our Prometheus on bare metal, so we have pretty beefy 32-core servers with 64 gigs of RAM to run that Prometheus server. But even if we didn't have that, it's still we just leave it totally untuned, and it's still only using 17 gigs of RAM. So if we were to squeeze that down, we probably could cut that resource usage in half. It's just there's no motivation there. Any other questions? All right, thanks.